now I am. Thank you. Y of x equals p of x over q of x, where p of x and q of x are polynomials. So rational graphs are fractions, something divided by something. The way I remember that is look at the first 5 letters of the word rational. What do you see? Ratio. What's another name for a ratio? A fraction. So that's how I remember radical versus ratio, because those can sound very similar. So ratio, rational, fraction. The non-permissible values, do you remember that word from last year? Remember we found them like 1,000 times after every question was like, find the NPVs. Become asymptotes, and you should remember that word as well. There's a masher that says, kiss my asymptotes. I didn't make it up, I'm just saying it exists. So we're going to look at the different shape of rational graphs. Again, some of these you saw last year, some are new this year. We're going to look at what do they look like if they have 1 vertical asymptote. What do they look like if they have 2 vertical asymptotes? And what do they look like if they have no vertical asymptotes? And then we're going to add on this thing called graph with holes. I know, it's totally crazy. Now, if you remember anything about asymptotes, they have to be drawn with rulers and they have to be drawn in red pen. So should you require one of those 2 instruments, you would want to get it now.
Yes, technically not. You could have the broken
Isn't a ruler a ruler?
Some of them are better than others.
Oh, which are, you like the floppy ones. He likes the other, the non-floppy ones. That's the shatterproof one for idiot children. Probably shouldn't have said that into the microphone, but.
You got some.
Was that a part of my box? Can you throw that out when you're done with it? Just a reminder, asymptotes are in red. They're not in pink, they're not in orange, they're not in blue with a note saying this is red. They're not in black pretending to be red, they are in red. So I'm going to throw it on the y-axis. It doesn't have to be. It can be anywhere on the graph as long as it's vertical. And last year we kind of talked about, but didn't really talk about horizontal asymptotes. They're going to come back this year. So we're going to put one on the x-axis, and I'll talk about them a little later on. And here's the shape that should look familiar. So we know that asymptotes can't be crossed, so the graph will approach each of these asymptotes on the left-hand side. And then it will have a mirror image on the right-hand side, also approaching each of the asymptotes. Does anyone remember the very fancy name mathematicians gave this graph? Because we are not creative people at all. We're slightly more creative than that, but we're really, it's volcano. These are all going to be called volcano graphs. Because it looks like the lava shooting up from the volcano. That's as creative as we get. That's it. We are sometimes really sad, nerdy people. Last year you would have looked at what we call variation of volcanoes, so it's still going to have 1 vertical asymptote, and again, doesn't have to be on the y-axis. I'm just putting it in the middle because I like symmetry. And it's going to have 1 horizontal asymptote, doesn't have to be on the x-axis.
So the easiest place to put them is the axis.
Yeah, because I like symmetry, so I like it to be in the middle. So the first variation of volcano graph, which you should have seen last year, starts the same way. So it's got this piece in the top left corner that approaches each of the asymptotes. But instead of the symmetric piece being on the right, it's on the bottom right. Doesn't look like a volcano, but it's in the same category because it has 1 vertical asymptote. And the pieces don't have to be in quadrant 1 and 3. They can be in quadrant 2 and 4. So it doesn't matter where they are. It's just still called volcano graph. Do Do you remember seeing these last year? These should look familiar. You graph them on your calculator, we sketch them. This third one, which is also a variation of volcano, you did not see last year because you would have cried. So don't freak out when I show you this variation. Still has a vertical asymptote. But instead of having a horizontal asymptote, it has what's called an oblique asymptote. Has anyone taken physiology or biology? Where are your oblique muscles? They're along the side. They're the ones that let you turn from one side to the other. So this has a sideways asymptote. It's called an oblique asymptote. It can be the other way. Yeah, just as a slanted asymptote. It's not completely horizontal. And I'll talk about these a lot more tomorrow.
So kind of like their flexion line versus axis.
Yeah, but it doesn't have to be. It could have a different slant to it. It just means it's not horizontal. It's a slanted asymptote. And so you kind of get this stretched out volcano feeling. And they don't have to be on the left and right. They could be kind of in those other two sections created by the asymptotes. So still called volcano because it is one vertical asymptote, but just looks a little bit different. So the first two you should have seen last year. This one will be completely new. We didn't introduce oblique asymptotes to you yet.
What kind of equations will give you?
Oh, you'll find out in a second. They're so pretty. Then you looked at two vertical asymptote graphs, which are my favorite graphs in the entire world. That's where there's one on the left and a symmetric one on the right. And again, we didn't really talk horizontal, but there ends up being one at the x-axis here.
Because like when I learned it last year, or basically all of JR said is the horizontal asymptote is the x-axis.
Well, because in the grade 11 curriculum, it says specifically, do not mention horizontal asymptotes. But that's stupid when suddenly this year it's like, surprise, there's horizontal. Why wouldn't we just talk about them last year? So we do, but we don't. So
they just
yeah, we just kind of squeeze it in there.
they just introduce the concept and say, hey, it's always the x-axis.
But it won't always be this year. So you get a volcano on the very left and you get a volcano on the very right. What happens in the middle? You get the parabola on the other side. So if the volcanoes are above the x-axis, the parabola is below. If the volcano pieces were below the x-axis, the parabola would be above. Favorite name of any graph in the entire world. Sad clown face. I kid you not. I am not making this stuff up. So the volcano pieces are the eyes, and the parabola is the mouth, and the asymptote are the tears. So he's like a crying, sad clown face.
No one's gonna believe you're smart as a mathematician.
I know.
Like, yeah, I just did a sad clown face.
Honestly, I think some mathematicians got drunk, and that's what they came up with. That's probably what happened. I swear alcohol had to have been involved with that. Do you remember seeing this one last year? Okay, so we're going to add in the second one, which you did not see last year. Still an asymptote on the left. Still an asymptote on the right. So still two vertical asymptotes.
And probably still horizontal one on the x-axis.
Yes. Or somewhere else. Doesn't have to be on the x-axis.
That's just weird.
It's because it's symmetric. We like things that are symmetric. You still get a volcano piece on the very left and a volcano piece on the very right. When you have those drawn, look up and watch me. Don't try to draw this middle piece at the same time. You have your two volcano pieces on the left and right, then watch me. In the middle, you get this. What kind of graph is that? It's a cubic. That's why we didn't introduce it last year, because you hadn't seen cubics yet. You would have cried, been like little babies on the floor in the fetal position.
Like the clown faces that we just
Yeah. You get a cubic in the middle. Yeah, it's like a volcano, but then not a volcano, and kind of has a tan graph feel to it, but not really.
So what would that be like?
Don't spoil tomorrow. No spoiling. So just to recap, these two you saw last year, we've added this one, which is new. The only difference is it's got a slanted asymptote. This you saw last year. This one's new, and it's got a cubic in the middle instead of a parabola. A no vertical asymptote graph you saw last year. It still has a horizontal asymptote somewhere. And it always looks like this. It approaches the asymptote at the left. It's got a little tiny bump in the middle, and it approaches the asymptote on the right. Speed bump. Which clearly who named it does not live on the prairies, because that's like a freaking mountain to us.
Especially for people over in Saskatchewan.
Well, we're not. We're pretty flat too. We're not much better than them.
Yeah, but at least there's some hills and trees and stuff.
Speed bump you saw last year?
Yeah.
This last one you have not seen, so this is new. So all we've done is taken the types you saw last year and added one new one to each of it. This one I want you to put literally an O somewhere on your graph. It didn't have to be in quadrant 1. I just put it there because I like quadrant 1. And I'm just going to draw a line around it. There you go. It's a graph with a hole. It's just a graph with a hole in the middle of it.
Fascinating.
It's a graph with a hole. It's got a hole right in the middle of it. Yeah. What do you think we call it? Graph with hole. This is where the alcohol started to wear off.
I don't know, I think it's just got more.
Just a graph with hole.
There's
a hole.
Must have been boozed up when they invented that.
But it was wearing off at that point. We're like, yeah, we're tired. Let's just graph with hole. Done. High five. Let's go
But
home.
like they're probably boozed up when they invented a graph with hole in the first place. Not the name, the actual graph.
What we're going to do today is just practice finding horizontal asymptotes, and that's where we'll stop. Tomorrow we'll pick it up with these horizontal and oblique. So we're just going to do vertical because you did this last year, so it's pretty much the same. Here's the steps in case you forgot. You factor everything you can, numerator, denominator, left-hand side, right-hand side. If you can factor it, you factor it. What didn't happen last year is nothing ever canceled. This year it will. If something cancels, it's a hole. If it doesn't cancel, it's a vertical asymptote.
Then where do we place this?
Oh, that'll come tomorrow. So you factor everything you can. If a binomial cancels, it's a hole. If it doesn't cancel, it's a vertical asymptote. You didn't have any last year that didn't cancel. They were all vertical asymptotes. Grab some paper, which I'm sure you already have ready, because you know how this works by now. It's a tough, lazy choice there. That's tough. Really, you picked walking over opening binder? Wow. You got to reach down. Which, by the way, I put 500 sheets of paper there in September. When it's gone, it's gone. And it's November, so you may want to pace yourselves.
I'll contribute to the
500 sheets were over there.
It'll happen at the semester break. Will you just
Maybe that's
Then I'll put another $500 back. Or you're too lazy to open your binders. Either one. You did this last year in 2 different units. It's the same thing as finding the non-permissible value. So NPVs, we found a bajillion times, it hasn't changed. First thing you do is factor anything you can factor. Can we factor x plus 3? How do you know?
Because it's a single degree equation.
So it's not squared, and there's no common factor. So those are the 2 things you're looking for. Is it squared? Is there common factor? Can we factor the bottom? How do we factor it?
It's a difference of squares.
It's a difference of squares. What happens with the x plus 3? It cancels. What that tells you is there is a hole at x equals -3. Is everyone okay where the -3 came from? So x plus 3 equals 0, solve for x. Did the x minus 3 cancel? No, that tells you it's a vertical asymptote. At x cannot be 3. Watch the notation difference. That's it. That's how you find vertical asymptotes or holes. If it cancels, it's a hole. If it doesn't cancel, it's a vertical asymptote.
Whenever we see a second degree equation in this unit, it will always be factorable.
Nope. Nope, there'll be some that aren't, which might result in those crazy graphs we didn't see last year. Just saying. Factor anything you can factor. Can we factor the numerator?
Yes.
How? It's not squared.
Common factor.
Common factor of 2. Offer of x plus 1. Can we factor the bottom? So he stays x minus 4. What's the conclusion? He's a vertical asymptote. X cannot be 4. Now, you might be thinking, well, I could see that without factoring. The reason I factor the numerator anyway is because when we go to actually graph these, we need it for something else. So I just always do it in step 1, and that way everything's factored and you don't have to come back and do it later. So even if you can see it's not going to cancel, just factor it because we need it later. Do we have an offer for the top? I think I heard x plus 2, x minus 1. Does it cancel? No. Conclusion, therefore, vertical asymptote. X cannot be -1. What's going to happen, because we did this last year, is you're going to want to make them cancel because it looks like they should. So you're going to start doubting yourself and thinking, maybe the top should be x plus 1. They're not always going to cancel because we're going to have vertical asymptotes, we're going to have holes. So don't make something cancel if it's not. Offer for the top. L's rocking this over there. X minus 4, x plus 3. Can we factor the bottom? Yes. So I'm going to grab my red pen. We talked about it in grade 10. We also talked about it in identities. We talked about the situation where you've got A minus B over B minus A. Do you remember that from identities? And so we've got this x minus 4, and we kind of have the same thing over here, except the signs are different. And I said to you in identities, you can cancel this, but what is it equal to? It's equal to -1. The reason that is because what we're going to do is factor a negative out of the bottom. That's why mathematically where this is coming from. So I'm going to take out a common factor of -1. So 4 divided by -1. And I'm going to put it in the second spot. You'll see why in a second. And negative x divided by -1. x. Why did I do that? Because now I can cancel it. That's why when you cancel it ends up being a negative. So yes, it can cancel, which means whole at x equals, I heard 4 and I heard negative 4. 4, negative 4. Are you sure? Are you sure?
Negative. Oh wait, I think negative. Negative and negative.
Okay, how do we usually do this? Well, we take the bottom, we equate to 0 and solve. How do you get rid of this negative that's in front? Divide by negative 1. What's 0 divided by negative 1? So x cannot be, or x is equal to 4. It's really important you see this factoring thing here because it's a whole. If you didn't, you'd think it was a vertical asymptote, which completely changes the graph. Okay, so it's this situation here is where it's coming from. I'd like to pause, pick it up tomorrow. How do you guys feel? Did I kind of put rational graphs back in your head? A little bit. Here? But it's not on the bottom. It has to be a vertical asymptote on the bottom.